Hi there, Pre-Calcers. We're going to try to do a couple lessons in this video session today, 5.2 and 5.3. First of all, trig ratios in right triangles. Here's something you probably have seen before. This is a right triangle, as you can see. Right triangle designated with that. Basing our focus on this angle theta here, we have three important sides in any right triangle. The side that's always next to the angle you're looking at is called the adjacent side. Next to, adjacent of course. The side that is across from that given angle is the opposite side. And then of course that longest side in a right triangle is the hypotenuse. Of course the adjacent and opposite might change depending which angle we're looking at. These other two sides here are also called legs of a right triangle as well. That's some basic info. Now here's some stuff you've probably seen before. In a right triangle, here's our main three trig ratios: sine, cosine, and tangent. And SOHCAHTOA, that's probably something you've seen before. It's a helpful way to remember those. Sine, again, if we're going from this B here, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, again, based on this B angle here, is opposite over adjacent. So the SOHCAHTOA, as we mentioned, is a helpful way for you to remember those things. Now we also have some other trig functions that would be good for you to write down. In addition to these main ones here, sine, cosine, and tangent, we have the reciprocal trig functions: cosecant, secant, and cotangent. And as you can see, they're just going to be the reciprocals of the main sine, cosine, and tangent. So it'd be good for you to probably pause this video right now, write all these things down. You will be given a trig card which also has this information on, but it's good to have them in your notes as well. Alright, here's the first example we want to take a look at here. And so let's say we have this particular right triangle here, and I'm going to label this side as 8 and this side as 15. I'm going to also label the sides here. This is going to be my right triangle, obviously. This is going to be angle B and C and A. And what we'd like to try to do is find the 6 different trig functions. So sine, cosine, tangent, and then the reciprocal ones, cosecant, secant, and cotangent. So let's see if we could write these down here. Now the first thing you might want to do is figure out what this hypotenuse is going to be. And in a right triangle, of course, we have a squared plus b squared equals c squared. In this case, if you do those calculations, this ends up to be a nice right triangle, so that the hypotenuse here is going to be 17. You can figure that out for yourself if you need to. So what I'm going to do is, just for angle A, I'd like to try to figure out what is the sine of A, the cosine of A, and the tangent of A. And we should be able to do these pretty well now when we have all of our values here. Of course, sine from my angle A here, opposite over hypotenuse, so that's going to be 8/17. Cosine, adjacent over hypotenuse, that's going to be 15/17. And tangent, opposite over adjacent, will be 8/15. Now I'm going to change colors here, and then I'm going to do the reciprocal ones. So the reciprocal ones are cosecant, secant, and cotangent. And those are just going to be the reciprocals of their corresponding trig function. Cosecant then would be 17 over 8. That's going to be hypotenuse over opposite. Secant is 17/15, and cotangent is 15/8. Now you'll have a chart for you to be able to do these kind of things. You don't necessarily have to memorize them, but if you do, it'll just help things go quite a bit smoother. Right. Next, here's something called the cofunctions. So this is a little strange and perhaps not the most important thing, but not a bad idea to look at those. What this means is, if I have something like the sine of 60 degrees, I know based on this chart up here that that's going to equal the cosine of 90 minus 60, or 30. And when we have our circle chart, of course, we'll be able to verify some of these things. but this would say that the tangent of 15 degrees will equal the cotangent of 90 minus 15, which would be 75. So kind of a handy identity little chart for you to go by here. These are called cofunctions. All right, next we're going to go to the next lesson. This is trig functions on the unit circle. And you'll have your unit circle that you can verify these. But last lesson was based more on triangles. Here we're going to base our trigonometry more on circles. This is the unit circle. A unit circle we mean has a radius of 1. And the idea here is we can draw a little triangle in a unit circle. This one's drawn in quadrant 2, as you can see. And my theta, of course, is this angle here. It's in standard position. And the very most important thing to notice here is x is associated with cosine, because cosine is adjacent over hypotenuse. And so when the unit circle is 1, your denominator will just be 1. So that's going to be associated with the x value. Sine then is associated with y. Sine, remember, is opposite over hypotenuse. So there's your y values there. So really, really important when we talk about cosine, you should be thinking x. Sine, you should be thinking y. We'll practice in class on this individual trig quiz, and a lot of that is based on this idea. Cosine is x, sine is y. All right, here's a circle chart similar to what you guys have. And you don't have to memorize this in order to do that individual trig quiz, but it's good to familiarize yourself with those. All these ordered pairs here, ordered pairs of course are x's and y's. So then for each of these angles here we really have a cosine and a sine. So that's what that should be able to help you with. Now a couple examples with this circle chart here. I'm going to look at 210 degrees, and could you tell me the values of the 6 trig functions there? Well, the sine of 210, of course, will be just what the y value is. So 210 is going to be, I'm going to focus on this ordered pair right here. So the y value, of course, is just negative 1/2. The cosine of 210 is going to be negative square root of 3 over 2. Now, tangents are not written on here, and we'll probably take some class time and write the tangent values on your circle chart. But tangent is the same as sine over cosine. So in this case, we'd really have negative 1/2 over negative square root of 3 over 2. And if we did a little multiplying or dividing by fractions, that'd be negative 1/2 times negative 2 over the square root of 3. The 2's would cancel out there, and negative times a negative is a positive. We'd get 1 over the square root of 3, and I could actually simplify that if I wanted to rationalize my denominator as the square root of 3 over 3. Alright, so that's how to find sine, cosine, and tangent of that. I'm going to skip over the other 3, but again, we could do that based on the definitions of those. Go to my final problem here, and it says suppose A is an angle in standard position whose terminal side lies in quadrant 4. If secant is 5/3, find the value of the other 5 trig functions of A. So first of all, I'm going to try to sketch a picture of what we're talking about here. Here's my grid system here. Standard position means that this angle starts at the positive x-axis, goes around like this. So to get in the 4th quadrant, my angle or my terminal side is going to look something like that. So here's my angle there. This could be considered then angle A, going all the way around like that. But when I actually label these, if secant is 5/3, we might remember that secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant will be hypotenuse over adjacent. So that's going to be 5, that's going to be 3, and you probably recognize there's your right triangle there. This is going to be one of these 3, 4, 5 right triangles. So when I label all the rest of these, so I'm going to have the sine of A, the cosine of A, and the tangent of A. I can just go right from this diagram here. So sine, of course, will be, again, I'm going to base from this little reference angle right there, opposite over hypotenuse, so that's going to be 4/5. Cosine, as we mentioned, is 3/5 adjacent over hypotenuse, and tangent is going to be 4/3. Now, the other thing you have to watch out for a little bit, I'd like to direct your attention over here. These are the sines in the different quadrants. And so you can see that when I'm talking about sine, I'm in the fourth quadrant over here. So when I'm talking about sine and tangent, those guys are going to be negative because, of course, y is negative there, and tangent will also be negative in that quadrant. Okay? And last thing I want to do then, I'm going to do the other reciprocal trig functions. So I have cosecant, secant, and cotangent. And those are just going to be the reciprocals of what we had written down earlier. So negative 5/4, 5/3, of course this is what we were given, and cotangent then will be negative 3/4. Alright, thanks for hanging in there, everybody. This is kind of a long video, but good stuff, and we'll see you guys in class tomorrow. Bye now.